Intro to Programming with Scratch 3. Scratch, off to a good start. Scratch is a framework for creating programs and games using simple to use drag and drop code blocks. Although it is simple to use, there are limitless options for what you can make. People from around the world have made games, comics, music programs, and so much more. This course has been designed to provide instructions on the use of the basic operations of Scratch. During this course, you will learn about the interface, the types of code blocks, combining code blocks. You will create a simple game and add sounds to your game as well. About Scratch. With Scratch, you can program your very own interactive stories, games, and animations, and share your creations with others in the online community. Scratch helps young people to learn and to think creatively, reason systematically, and work collaboratively, essential skills for life in the 21st century. Scratch is a project of the Lifelong Kindergarten Group and the MIT Media Lab. It is provided free of charge. Who uses Scratch? Scratch is designed especially for ages 8 to 16, but is used by people of all ages. Millions of people are creating Scratch projects in a wide variety of settings, including homes, schools, museums, libraries, and community centers. Learn to code and code to learn. The ability to code computer programs is an important part of literacy in today's society. When people learn to code in Scratch, they learn important strategies for solving problems, designing projects, and creating and communicating ideas. Around the world, Scratch is used in more than 150 different countries and is available in more than 40 languages. To change the language, click the menu at the bottom of the page, or in the project editor, click the globe at the top of the page. Scratch in schools. Students are learning with Scratch at all levels, from elementary school to college, and across disciplines such as math, computer science, language arts, and social studies. Educators share stories, exchange resources, and ask questions, and find people on the online communities. About the interface. The Scratch user interface is the area on your screen where Scratch program exists. The screen is divided into multiple sections or panes, which have different functions from picking blocks to code with, to coding, and to seeing your code in action. We will go through the different elements of the interface. The first one is the block palette. The block palette is where all of the code blocks exist. Blocks are color-coded by category. These blocks can be dragged into the scripting area to either code, sprites, or the stage. Number 2, the scripting area. The script area is where our code is dragged to and assembled. Number 3, the stage area. The stage area is where we can see our code come to life. For example, if we have a when green flag is clicked event block at the start of a code, we can click the green flag to trigger the code we wrote. That's area 3 here, and there's the code flag there. The sprite info pane, number 4 down the bottom here. The sprite info pane is where we can find out about our sprites as well as manipulate them. Access this pane by clicking on the thumbnail of the desired sprite. So if we have multiple sprites there, you would need to click which one you want to find out about. This area also allows us to delete and create new sprites. So let me just demonstrate that. We're switching over to the program. If we make the same one that we see there, and we're going to go in more detail how this is done in just a moment. I click flag and move 10 steps and then say hello for 2 seconds. Make sure that connects. When we run that, you can see over in this area, he moves a few steps and then he says hello for 2 seconds. The costume and backdrop pane. The costume and backdrop panes can be accessed by clicking the middle tab in between the code tab and the sound tab. This is where we can create and manipulate sprites and backdrops. Switch between the costumes and backdrop panes and select the desired thumbnail in the sprite info pane. So if we want to look at the cat's costumes and other ways that it can look, we can click on the cat first and then click on the costumes tab to be able to view them. The costumes tab will be different if you've chosen one of the backdrops. At the moment there's none, but if you were to choose one, then they would be accessed and edited through the button that would appear there. The sound pane. The last tab in the top left area of the interface allows us to create and manipulate sounds. You can even record your own. So the last one along there is sounds. We'll be playing with some sounds later on. Up the top of the screen we have the tutorials button up on the toolbar. The toolbar on top of the screen allows us to load and save projects, as well as undo the deletion of sprites. Find a variety of tutorials on how to do just about anything in Scratch by clicking the Tutorials button. So if you click the Tutorials button, this window will pop up, and you can either have a look through the ones that are there to get you acclimatized to the program, or you can do a search for something specific. Types of code blocks. Block types. Scratch is a block-based programming language. This means that instead of writing lines of code to program, we use blocks. Each block has a specific category that describes what its purpose is. Sprites are the objects that perform the action in a project, and these blocks tell the sprites what to do. Code blocks can also tell a stage or backdrop how to behave. The different type of code blocks. The first one is motion, and they are all this sort of darker blue color. They define the movement of sprites. So they tell a sprite what to do, where to move to, or how to turn, for example. Looks, the purple blocks, are ways that we can change the appearance of sprites. It gives the ability to change costumes and apply graphic effects. Sounds, play audio by recording sounds, using MIDI notes and more. Events, these light colored code blocks trigger scripts or series of code blocks. They consist mainly of hat blocks, which will start a script. We'll explain what that means a bit later on. Control. The darker coloured yellow or orange ones dictate the flow of a project, provide mechanisms for looping different blocks and scripts. Sensing. These light blue blocks let multiple sprites interact with themselves and or the stage. Can determine how two sprites collide, for example. Operators. These green blocks allow for various mathematical functions within a project that can be used to modify variables and strings. We'll be looking at variables a bit later on too. The variables are used to store data in projects, like a name or a score. In My Blocks, you can create your own blocks. I've not done that one before. That would be interesting. And there's also extension blocks down the very bottom left-hand corner of the screen. These blocks let you connect to hardware or access a number of other block types like the pen or music blocks. So if you have a graphics pen or you have the controllers that you can actually physically plug these into your computer and use them to control your programs. Combining code blocks. Now that we've had a look at the interface and explored the different code blocks, let's put a few together for our cat sprite and see what happens. This will also let us understand how the code blocks work and can be manipulated. Please follow along with the steps below. So I'm going to delete what I was showing you before and recreate it just so you can see how the blocks work. So I'm going to drag these over to here and drop them down, and they're gone now. If I go over to the Events tab, I'm going to click and drag this one over here, and then the next step is to go to Motion, and we're going to click the Move 10 Steps. I'm going to click and drag it. Once again, you'll see it when I put it here and let go, it'll snap together. When I go over to Looks, I can grab the Say Hello for 2 seconds. If I drop it here, it won't connect, but if I drop it here, it will. Now we can test when we click the flag over in this area here what happens. It takes 10 steps, which doesn't look like 10 steps, but believe me, it is. And then it says hello for 2 seconds. Click that again, he'll do it again. Click it again, he'll do it again. So that was going through these 4 steps here. Let's create a simple game. The basics for Scratch is made of multicolored blocks, as we've now learned. We will mostly be using the blue motion, the yellow control, violet looks, and the light blue sensing blocks. Now, let's teach our cat to run. We'll start by removing the code we added just before. To do so, click and drag them back where they came from. Note that you can click on the top level, the one with the when flag is clicked one, and drag it back into the block palette. Note that you can also pull code blocks apart by clicking them and dragging them apart. Let's actually have a look at that again. So I can grab individual ones and remove them and throw them away, or I can grab the whole thing and put it away. You can also do the good old Control and Z keyboard shortcut to bring things back and go through steps when doing that. So let's go to the event block group, and we're going to grab when space key is pressed, And then we are going to go to the motion group, and we're going to select move 10 steps. And once again we see that we get the shadow box there, and done. And then that's it, well done, you've actually made your first program. If you hold down the space key, you'll see that the cat will run to the edge of the screen, and then he'll actually get stuck there at the end. To bring him back again, we can grab him by his tail, click that and drag him back to the middle. And we can see that in the instructions as well. Holding down the space bar, moves off the edge and grab him by his tail. If you move the cat all the way to the left hand side of the screen, like so, and then count how many times you have to press the space bar to get him across. I'm going to do that now. Okay, so that was about 40 times for me. So if he's taking 10 steps each time, then the screen would be 400 steps long. Remember this number for later, it might come in handy. Let's now add a meow sound to our program. Press the light purple sound blocks and grab the play meow sound until done and drag it in. Now what happens when we press the spacebar key? So here we go, I've dragged the play meow sound over to here, and I press spacebar. That is very loud. So when I press the spacebar key, the cat now meows when he moves. If you are bored with this meowing sound, you may add a new one. For instance, you can make him bark. First you have to go to the sounds tab and then choose a sound button. Let's do that now. So we're going to go to the sounds tab, and down the bottom here we're going to click on choose a sound. We can restrict it to just animals. And if you put your mouse over them, you will hear the different sounds. We want the dog one here, so I'm just going to click on that. And then we get a way to actually edit the sounds as well. You have a play around here, make some pretty amusing sounds. For example, we make it slower, make it like a robot. You can do all sorts of fun things just with that editor. I'm going to go back to the code block, and now when we click on the down arrow in here, now that we've added dog 1, we'll find that that's in there as well. So let's select that, and now when I press the spacebar, it makes a very strange barking sound, I must say. In the previous versions of Scratch, there actually was a play button that you could press to get the tester sounds as well. So if you scroll down a few pages here, we went through the other things of the sound quite easily. On page 17 here. The first chapter is coming to the end, so let's save our project. We click File and then Save to your computer. So File, Save to your computer, and then give it a name. I've already done this a couple of times. I'm just going to go over my previous one called My First Project. You should type that in and click Save. If it does exist, you can opt to override it. Be careful you don't lose anything you're trying to keep. And anytime you want to open it again, you can click File and Load from your computer, and then find it and open it. I'm going to click Cancel for now. Chapter 2, Expanding the Program. Now we have this program. If you're bored with the barking of the cat, we can delete the light purple block by pressing on that block and dragging it to the bottom. The light block is now detached. We can then drag that one over. Let's see how we do that. So I can click on this block and drag it down. I can then drag it over to the block palette and drop it there. Now you have a program for the cat silent movement. Press the spacebar and the cat will move silently. Let's add a blue block named If On Edge Bounce. So under Motion, have a look down near the bottom here, If On Edge Bounce. This is a really handy one that allows us to not have to do complicated programming to achieve the effect. If I now click the spacebar key, when the cat reaches the end of the stage here, we'll see what happens. He bounces and turns around. If I hold down space, you'll see he'll actually move quite quickly and bounce backwards and forwards. At the moment we have 10 steps in there. What happens if we change this to 100 steps? I can simply click in here and click on the end and add an extra 0. By default, when you click into here, the whole thing is highlighted, so you can type whatever number you want. I'm just going to do 100 steps. I'm going to click out of it and now press spacebar and see what happens. If I hold down space, you can now see he takes quite large steps. Getting back to where I like him in the middle there. little question here: what happens if you change it to 10,000 steps, or 100,000 steps, or 1 step? Try around adding a few different numbers and see what effect that it has on them. Chapter 3: Forever Loops. Chapter 3: Forever Loops. Replace your code with the one seen here. What happens when you click the green flag for the program now? If you are having trouble getting the code blocks into place, or the program does not behave the way that you might expect, please view the accompanying video. So I'm going to remove the code blocks here. I'm going to go to Event and bring over when green flag is clicked. I'm going to go over to Motion, and I'm going to grab Go to X and Y. X and Y are coordinates that we use to track something in a 2D space. We have 2D space over here. I'm going to put something up on the screen here to demonstrate what the difference between X and Y axis are. Basically, you start at 0, 0 in the middle. So I'm actually going to type that there. 0 and 0 is in the middle of the screen. Anything to the right on the X plane is positive. Anything to the left is negative. On the Y plane, which is the vertical plane, anything in the positive is up, and anything is negative is down. We're going to use one of our first new blocks. Under the controls, we are going to grab what's called a forever loop. We're going to grab that in here, and once again attach it to the bottom. The next new thing we're going to use is the if-then block. Not to be confused with the if-then-else block, which we'll be using later on. We want just the plain if-then, so I'm going to get rid of that one again. Now, eventually these are going to end up in here, but I like to put mine outside of the forever loop to start with, so that I don't get confused with what's going on, and sometimes it can get a bit fiddly if you try and do it in there. Up next, we're going to go over to sensing, because we want something that's light blue, and the one in particular is if key is pressed. So it's actually sensing an input from the keyboard in this case. Now for this first one, we're going to choose right arrow, and then we're going to change the X. So rather than move block that we used last time, we're going to use a different one this time. We are going to go change by X. And we're going to set this to be 3. And that's actually the end of that if block. We're going to make another one now. I'm going to show you an easy way later on, but for now I'm just going to grab out a new if block, if then. Back to sensing and grab out another key. This time we're going to do left arrow, and back to motion, change by X, change X by, I always say that backwards, and this time we're going to do -3. I'll show you why in just a moment. I'm going to put these two blocks together, put them together in my forever loop. You'll see when I put it in there, it opens up. And now the forever loop is surrounding these two blocks. So now when I click the start button, our cat will move to the center. And now whenever I press spacebar, nothing happens because we don't have anything that says key spacebar. We have right and left. So I press right, he moves right. Press left, and he moves left. And this one's actually going to run until we click the stop because we have a forever loop. So I'm going to click the stop button. I'm going to pull these back out again just so I can see what I'm working with. And we're going to create another one, this time for moving up and down. So once again, we're going to go back to controls, create a new if loop. Once again, with the sensing, pressing a key in there, just to up arrow. And this time, instead of changing X, we're going to be changing by Y, because Y is the up and down. And we're going to change that to be 3. And then we're going to create one more. This time, rather than bringing them out, I'm actually going to right click on this one and select duplicate. That's the exact same. I'm going to change this to be down arrow instead, and change this to, you remember what this would be? If that was -X, this is going to be -Y by 3. Let's put these together and then put them all inside the forever loop. Click the play button. You'll see that I always call it the play button, the little green flag to go. And you'll see now if we press left and right, it moves left and right, up and down. Back in our document here, we can see the text down the bottom that explains that the forever loop works by running the code over and over again. In our program, it keeps looking for one of the 4 keys to be pressed, It tells the cat which way to be moved based on that key, and then continues running the program. Note that the code in the following pages starts to become more advanced. If you feel like you've had enough of programming, this is a good place to stop. In the following pages, we'll look at changing the costume, having a cat that moves at variable speeds. Here is a more complicated one that has several cool features. First of all, we can set the speed of our cat by either pressing the 1, 2 or 3 keys at any time whilst running the program. Secondly, our cat will look like he is walking by changing the provided costume and the purple switch costume command. Creating additional costume is also required to make him look good when he's walking left. So I'm going to move over to my program here. I didn't stop it before. Click the stop button. And I'm actually going to delete this one completely. You could modify it, but I'm actually going to delete it and make it from scratch as well, just in case you decide to come in at this project and you want to make it from the beginning. I can do that as well. So we're going to get rid of all of that. Once again, just a reminder, if you accidentally delete something like that, you can just do the Control-Z to bring that back again. So using my book as the reference here, I'm going to go and create under events. I'm going to, whoops, I clicked on sound then, I meant events. Click on the flag, and this time we're going to switch to costume right at the start. This is just in case the cat starts in a different position. It will always return to his default costume, which is this one here. We are then going to go to motion, and we are going to go to a position. Make sure that he always starts right in the middle. So the middle is 0, 0. And then first one of the new things is we're going to use variables. So variable is like a holding place for a number, or it could be a string of text. In this case, we're going to be using a number. So we need to first make a new variable. We're going to create 2 of them. We're going to create speed, and we're going to tick it for this bright only. Okay. And we're going to create another one called neg speed, short for negative speed. It sounds like a weird thing, but this is going to allow us to make the cat move to the left and down as well. Now that we've got those 2 variables created, we need to actually set them. Doing that at the start of your program is a great idea. So we're going to come here. We now have speed here. When the program starts, it's going to be 5. And for negative speed, we're going to set it as -5. That'll make a bit more sense when we get down a bit further on. We are now going to go over to Control and grab a forever loop. Put it in here. And we're going to grab a if-then statement, making sure I'm grabbing the right one. Yes, I am. And this is going to look very similar to the previously, where we go and put in the sensing if key is pressed, and we're going to choose right arrow. This time we're going to do it in a different way to make the cat move. First of all, we're going to change the look, and we're going to switch costume 1. We are then going to grab a control, which is wait 1 second, so that's the darker orange ones. Wait 1 second after that, so you see I can move it around and it tries to put it in a different spot. We want it to be after. 1 second is a bit long, so let's do 0.05. And then we're going to tell the cat to move a certain amount of steps. Now we're not actually going to use this variable, this code block here. We're going to use the change x by, and this time rather than leaving a number in there, we're going to actually use our variables. So back to here, we're going to grab speed. We don't want negative, we want normal speed. Pop that in there, and then we're going to change the costume back again. So switch costume 2. The other costume 2. Let's put this in our forever loop and see what happens when we press the right arrow now. So first of all, clicking the flag made him go back to 0, 0, because this part of the code tells him to. And I'm going to press right, and we'll see that when he walks now, he has sort of a walking animation. At the moment, we don't have left, up or down set, so only right works at the moment. But you can also see, if I have him in that costume, and I press stop, when I click the flag again, it should put him back to the middle and put him back to the original costume. There we go. So now stop that again. So now I'm just going to go through and add the other if statements for the other directions. I'm just going to pull this out again so we can refer back to it. I am going to make things a bit easier by right clicking and going duplicate. This time we're going to do left arrow. and we're going to need some different costumes, which we'll set up in a moment. And we want to use a different variable this time. We're actually going to use the negative one. So under variables, neg speed goes in here. We can get rid of that one now. That means it'll do the neg speed, which is -5. So when we press left, it'll actually go this way. Now, to make the costume look a bit better, at the moment, if we do this and test it, and this is a great thing in programming to do, is always test your work as you're going along. Right works fine, left technically works fine, but it looks like he's doing the moonwalk, which might be the effect you're going for. However, I want him to actually turn around. Let's make some new costumes. Making sure we have our cat icon selected, our sprite, I should say. Under the costumes tab, we can see the two existing ones that he's switching between. I'm going to click on the first one, and then I'm going to right mouse click, so the other mouse click, and duplicate. That makes number 3. I don't know why it puts it in order like that. I want him at the bottom, and then I'm going to do the same for the second costume, duplicate, and put number 4 at the bottom. So now it's costume 1, costume 2, costume 3, costume 4. So this is a copy of the first one. We have an option here to flip horizontally, done, and the same for costume 4, done. So we now have 2 costumes for going right and 2 for going left. Let's see how that looks back in the code tab. If we're going left, we want to switch between costume 3 and costume 4. Alright, once again, let's give it a quick test. Put it inside our forever loop and run it. And now going right looks good and going left looks good. Excellent. You don't have to pull the code out like I am. That's just the way that I like to do it. I think you'll find most programmers have their own way of doing things, each to their own. So now I'm going to create 2 more of these, one for going up and one for going down. Controls, if then, sensing, key. Let's do up first. That's the same as what it is in the documents, up arrow. And then this time, remember, we have to change the Y. Let's put in the costume change first. That's sounds. I want looks. Switch to costume. We'll do 1 for going up and the 3 and 4 for going down. Then we want to wait a moment actually. So put in wait for 0.5 seconds. 0.05 I mean. And then we're going to go back to motion. Now, going to be careful here. We're going to change Y by instead, because we're going to be going up and down. So these ones are both X and these ones are Y. Going up is a positive Y motion. So let's go to variables and use the speed, not the negative one. Back to looks and costume. And I do need to change that one to be costume 2. And now that one's done as well. I might actually duplicate that. You can see, even though it's connected, because I right clicked here, it only duplicates it there. So we're going to change that to be the down arrow, and costume 3 and costume 4. Once again, we need to change that to be a negative. Neg speed. Lovely. So the up one was a positive, and the down one is a negative. Grab this one back over to there. And now I can grab this whole entire 4 different keys and put it inside that forever loop. I'm just going to zoom out just a little bit with the control and scroll wheel. I think there's actually a button. I was looking at that one. Clean up blocks. Sometimes that will actually center your content on the screen, but try zooming in. Clean up blocks. No, I guess I changed that a little bit. That's fine. If you do have little bits of blocks all over the place, then right clicking and clean up blocks will tidy things up. That's fine, we'll just leave that there. Okay, the next bit of the code is adding these 3 other little separate blocks of the little hat blocks here when a key is pressed. So rather than using the if key, whichever is pressed, we can do it a different way. This is used for when you're in the middle of a code block or in a loop. These ones are done for separate ones. So back over here, we have when space is pressed. We're going to change that to be 1. You can't actually type in there. You have to actually go down and find the one that you want. And we're going to do 2 variables. We're going to grab out 2 of those. You could duplicate it either way. Change that to speed and this one to negative speed. I'm going to set the first one to be 5 and negative 5. Then I'm actually just going to copy this twice, or duplicate it, I should say, duplicate and duplicate. This one's going to be button 2, all the way down to the bottom, number 2. And this one's going to be, let's see, 15 and negative 15. We can also just sort of get in there and do it that way. And then finally, number 3. This one is going to be the maximum speed, which is 45. It's not actually the maximum. This can be the maximum for our character. And you could come in and change this as well and play around with different numbers in here too. Right, when we actually push one of the buttons on the keyboard, if I actually push and hold the 2 button, you can actually see this one actually lights up, and 3 makes that one light up. If I run the program now, by default now, of course, the cat switches to costume 1 and goes back to the starting position. Now if I press the right key and left key is a little bit jittery on the motion there, up and down, looking good. If I press number 2 key on the keyboard, you'll actually see the speed change up there. So now he moves a lot quicker. Happens if you push 2 keys at once. It actually kind of goes diagonal, that's kind of funny. And finally, if I push number 3 key, he'll go absolutely full speed ahead. That's pretty cool. Right, press stop. Back in our document here, we go through in the document how to change the, make the additional costumes, which we have already done together in the thing. So just a little note here that if your cat isn't doing what you expect them to be doing, don't worry. All programs are bound to have some bugs in them, and it's usually just a process of reading through the lines of code. Reading aloud, I find, helps, and see what's not right. For example, you might have done accidentally the wrong key press, or you've done positive speed instead of negative, or vice versa. On the next few pages, we're going to add another sprite with its own code. Once again, if you've had enough, this could be a good place to stop. Completely up to you. We're going to add a new sprite to our program now and give it its own code. We are creating a ball that will bounce off the wall, pick a random direction between 1 and 45 degrees before continuing. This code uses an if-then-else statement to check if it's on an edge before it sets a new rotation. We're going to create a variable called rot to represent that one. Adding a new sprite by clicking on the Choose Sprite button down the bottom. So I'm going to click on the Choose New Sprite button down here, and I'm going to click on that. We get a nice big list here. I'm going to type in the search here. I'm going to type in ball, B-A-L-L. I'm going to pick the basketball. You can choose a different one, but I don't recommend using one with limited texture on it because you won't actually see the rotation happening. So I'm going to choose basketball by clicking on it once. Now you might think your code's actually disappeared, but it's not. Each of these sprites has its own code. So clicking on this one shows me the cat's code. Clicking on this one shows me the basketball's code. Here's the code block that we're going to add for the basketball. It's a bit shorter and it uses some things we might be familiar with and a few new things as well. Under events, we're going to go when the flag is clicked. It's going to go for another one of these motions. It's going to go to a position. I'm going to actually set that just to be 0, 0, so this starts the same place as the cat does. Let's see. Now we're going to need a new variable. Make a new variable. I'm going to call this one ROT, short for rotation, once again for this sprite only. And then we're going to set what that variable is going to be. I'm going to choose from here. I'm actually also going to zoom in. Let's set that and then just zoom in a bit so we can see a bit better. Now, this time, rather than setting it to a number ourselves, we're going to use an operator, another brand new block in the green ones, and we're going to actually choose pick a random number between 1 and 45. And that'll pick a number between 1 and 45 to use for the next part, which is under motion, another new block we're going to use, turn a certain amount. Now, we've just set a random number to a variable. So we can just call on that variable, like so. So now when you click the flag, it'll pick a random direction and turn in that direction, as if it was an arrow pointing in a direction. We're now going to need a forever loop on there. This is looking a bit familiar now, hopefully. Next up, we're going to grab a motion. We want the ball to, after it's rotated, move 10 steps in that direction. We're going to use one of the other if. So this time we are using the if, then, and else, and I'll explain that in a moment. Back to sensing, we need a, no, not that one actually, not key press. We actually need touching. There we go, that's the one. And instead of mouse pointer, we're going to change it to edge. So if it is touching the edge of the screen after moving 10 steps, then do something. What's it going to do? Under motion, we've got a handy one which makes things easier. It might sound a little redundant, but if on edge, bounce. So when it touches an edge, if it's touching, then it will bounce off. After it bounces off, we actually want it to change the variable. So after it's done that, it's going to pick a new direction to turn to. So it's going to set the rotation to be back under here, a new random number. So let's change that to 45 again. So every time it bounces off the edge, it'll pick a new rotation. At the moment, it won't do it though. We still need to tell it, okay, you've picked it. Now, turn to be it. So under motion, turn how many degrees, but we're going to use that same variable again. So every time it hits the wall, it's going to rotate and turn, and then go back to the start again and move. So it's going to keep doing this little loop forever, once we put it inside the forever loop. Now, if it moves 10 steps and it's not touching the wall, so sort of the opposite of this, what do we want it to do? We actually want it to keep on moving. So move 10 steps. That all looks good to me. I'm going to grab up this whole code block and drag it here into the forever loop. There we go, and let's test it. So now when I click the flag, it runs the script. So the ball starts in the middle, it picks a random rotation, turns that degree and starts moving forward. So as you can see, this number here, the baseball ROT, the rotation variable, every time it touches the wall, it changes the number. If I actually stop this, we'll be able to see it easier. If I make the steps, instead of 10 steps, let's do 3 steps. 3 steps. And run it again. Now the ball moves much slower. So you can see now that the rotation is 11. When it gets to a higher number, it'll be a much sharper angle. 36, 17, 2. Now while the script is running, I can also do the script for the cat. So I can move left and right and up and down and change my speed. And these two scripts are running independently of each other. So just to finish up here, note that the files that I've created here on the during this video will be available on the Google Classroom site. There's obviously a lot more that we could add, like having the basketball reverse direction if it touches the cat, a basketball hoop that you can try and score points in, a scoring system to count these points, and so on. I hope to run additional classes in Scratch in the future, so please let me know if this is something of interest, or if you know someone who might like to make their own games.